Okay guys, so welcome again on our Palo Alto Firewall demo class. This is Hemu. I'm a Palo Alto instructor. So let me just tell you some details about our Sianets.com. So if you will type on Google Sianets.com, this is our website. And if you want to check out, these are the course list which you can check. And let's suppose you want to check for the Palo Alto course. If you click on Palo Alto, it will take you towards all the details where you can find everything along with the course content. All the details is mentioned here. You can download the course content from here. Apart from this, we do have a one YouTube channel. That YouTube channel name is Skilled Inspirational Academy. So if you will search on Google, you will get that particular YouTube channel where you can able to find our F5 Ltm, GTM, ASM, Palo Alto, Python, FortiGate videos. How we will teach, you can basically check these things as well. Apart from this, we do have another YouTube channel. Name is NST Firewall. If you will type on Google NST Firewall YouTube channel, you will get this particular channel link where you can able to check out if you want how we will teach. So we have a multiple videos on Palo Alto, FortiGate, Python. So such kind of video you will get here. Apart from that, we do have our application. So if you will, our application name is Skilled Inspirational Academy. That application available on YouTube. Sorry, it is available on the Google Store. From there you can able to download. So my team, they will share the link of that channel as well, where you can able to check out our video based training for Palo Alto PCNS training, F5 Ltm, F5 DNS, then Palo Alto advanced tech. So this is the tech level training, guys. It's a more than 70 plus hours of training where you can learn the advanced troubleshooting, or it's just a same training when you are joining the Palo Alto Tech. So you have to go through such kind of trainings only. So all these things, all such kind of details is included in this particular course. Apart from that, we do have a one advanced training on F5 advanced ASM training. So you can also check out this particular training as well. Okay, so this is something about our site, YouTube channels, our applications. Now, let me just give you some brief about that. So what are the things we've generally covered if someone join us for the trainings? So in Palo Alto Firewall, it's a 32 plus hours of training. And guys, my main focus is on your PCNSE. Whatever syllabus you have a PCNSE, I will cover each and everything. Apart from this PCNSE, what I will also focus on how you can deploy the Palo Alto Firewall, how you can troubleshoot the Palo Alto Firewall related issues in an organization. That is 32 plus hours of training. You will get the lifetime interview support. You will all get the lab workbook. You will get the lifetime recorded videos. You will also get the help on lab setup. So I will help you building the lab in your laptop. Let's suppose your laptop is not having a good resources. Then you can also able to build the lab on the Google Cloud. And if you will subscribe by using your credit card for the Google Cloud, you will get a 300 USD free for 3 months. So you just need one credit card to subscribe for the Google. It's a weekends batch, and I will always available over the weekdays between 5 p.m. to 6 p.m. So if you want to discuss any kind of live issues, what let's suppose such kind some of the issues which you have faced in your production environment, so you can discuss with me and I will give you the best solution. We will also provide the mock interview support, which means let's suppose you have an interview on Palo Alto Firewall or on F5. You can call us just 4 days before and we will guide through how you can prepare the things. We will ask few questions and after that we will judge where you are lagging and we will guide you what are the things you have to prepare. So this is the thing which we will basically, this kind of support you will get. Now let's discuss Palo Alto Firewall course content. What are the course content I am gonna cover in this particular training? So if I talk about the course content, then So let me go down somewhere. Yep. So my course content start from here. So in day one class, we will discuss platform and architecture. In this platform and architecture, I will include the Palo Alto single pass architecture, how SP3 works. What is SP3? What are the different components involved in SP3? And platforms, I will discuss what kind of hardware models we are having. What are the virtual models we are having for Palo Alto Firewall, which we can deploy in our organizations. What is the flow logic? So we will discuss the life of a packet inside the Palo Alto Firewall. How Palo Alto process the packet, what is ingress processing, what is flow lookup, then we have a slow path, then we have a fast path, then we have a app id, then we have a content id, then we are having forwarding, right? All these particular stages we will discuss in detail in your flow logic session. And after that, I'll just move towards your initial configuration. Initial configuration includes, let's suppose you have a new, you got a, or you receive a new Palo Alto firewall. Now, how you can configure the management interface of this firewall? Why using CLI, by using graphical user interface, how you can connect your management, how you can connect with your console port of your Palo Alto firewall, how you will connect your management interface with the switch, how you can do the basic troubleshooting, how you can register your Palo Alto firewall with the support portal, how you can do the licensing. All these details I will discuss in this particular session. What is the default username and password we have for Palo Alto firewall? All these things we will see. Then we will see the configuration management, where I will tell you how commit works. What are the different options we are having for taking the backup of configuration, saving the configuration, how we can export the configuration, how we can load the configuration. All these things we will discuss in the configuration management. Then we will see licensing and software updates, how we can do the software updates, what are the things we need for software updates, well, how we can do the basic troubleshooting for that. Then we will see the account administration, where I will explain how we can add the username, or how we can add the admin for L1 engineers, L2 engineers, L3 engineers, right? How we can manage all these things, how we can create a role-based access. So we will see all these details. And after that, I'll move towards your interface configuration, where we will see different types of interfaces, how we can configure the security zones, what is layer 2, layer 3, virtual wire and tap mode deployment. We will do labs on this particular deployment. Then what is the concept of sub interface, how we can basically configure these sub interfaces. Then we will see how we can configure the DSCP on Palo Alto firewall. So how we can make Palo Alto as a DSCP client, how we can make Palo Alto as a DSCP server, and how we can configure Palo Alto as a DSCP relay agent. So all these three labs we will do. Then I will explain you what is virtual routers, how we can configure the routing on Palo Alto firewall. What is the multi virtual router setup? What is the use case of this particular multi VR setup? So we will see this thing in detail. And when we complete with this part, I'll just move towards your security policy and net policies, where we will see how we can basically configure the security policies, how we can configure the different types of net rules, how we can do the policy configuration by using graphical user interface, which is most of the time we will do, but how we can basically do the same thing by using CLI, how we can create a config template for this. So I'm gonna explain everything. Then we will see what is source net, what is destination net, what is U-turn net, what is source net. Then in destination net, we will see three use cases. Like by using the single public IP, we can host one server. Then on the single public IP, we will host multiple servers. How we can do the port forwarding. So all these kind of use cases we will see in your net class. Then I'll move towards your app ID. How Palo Alto Firewall do the application identification. how it will basically process, what is the app ID operation. All these things we will see in detail. What is the concept of application groups, application filters? We will see all these things in details with the lab, where I will show you how we can allow the Facebook, we can block the Facebook chat, how we can create a application group for media streaming application where we can block YouTube, Netflix, all such kind of video based traffic. So all these details we will see. How we can basically create a filters on the basis of risk level, risky application, and how we can use them in our security policies. So we will see everything here. And after that, I'll just move towards your content ID, which is your CTD engine, where we will see what is antivirus profile, what is anti-spyware profile, what is vulnerability profile, what is URL filtering, what is external dynamic list, EDLs, file blocking, wildfire. All these things we will see in detail with practicals. I will download some kind of antivirus from the outside and we will see how my firewall is blocking this antivirus. I will launch some kind of, I will try to exploit some kind of vulnerabilities of my Windows server by using the Kali Linux, and we will see how my firewall is protecting us. We can see how we can use the URL filtering. What is the exact concept of URL filtering in Palo Alto? So we will see in detail. Then external dynamic list, how we can configure the external dynamic list by using the internal Linux server. In file blocking, I will show you how we can control the files, uploading of the files, downloading of the files, how your wildfire works. So we will see in detail. Then we will see how zone protection and DOS protection works. In your zone protection and DOS protection, I will tell you what is SYN flood attack. What is ICMP flood attack? What is UDP flood attack? What is IP flood attack? What is host sweep attack? And I will launch such kind of attacks by using my Kali Linux machine. I will launch these attacks and I will tell you how my firewall is protecting from these kind of attacks. So we will see practical implementation of such things, guys. Now I will move, after that I'll just move towards your most important topic, which is decryption. Or we can say I'll move towards your SSL decryption. How we can basically decrypt the SSL based traffic by using Palo Alto firewall. How we can create a certificates for that. What is the concept of certificates? We will go in detail with the SSL handshake, how your SSL handshake works, how your outbound SSL decryption works, how to configure, how my Palo Alto firewall modify the certificate chain. All these things we will verify by using the Wireshark captures, which basically engine will take care of your SSL decryption, how that engine triggered, everything we will see in detail. Then we will also see how your inbound SSL decryption works. What is SSL decryption, or we can say what is SHS proxy? Because nowadays people are launching attack by using this SHS proxy, by using your SHS tunnel, how we can basically protect from such kind of proxies. Then we will also see what is the user ID, how we can configure the user based policies, how we can integrate our Palo Alto firewall with Active Directory, how we can integrate our Palo Alto firewall with the Radius server, how we can use the inbuilt Palo Alto user ID agent, so it can fetch the, it can read the security login events from the Active Directory, how we can configure, how we can create a service account on your Active Directory server or in your domain controller. So all these things we will see in detail, like AD integration, user to IP mapping, how we can configure user to IP mapping, how we can, what is the user ID agent, how we can configure it. Then after that, I'll just move towards your site to site VPN. And site to site VPN, we will see the detailed, I will explain in detail how your phase one exchange works, how your phase two exchange works, or we can say how your main mode works, how your quick mode works, how your aggressive mode works. And apart from this, I will cover around 13 use cases in Palo Alto Firewall for VPN, how we can configure these kind of VPN use cases. Because if you will go to work on Palo Alto Firewall, majorly you are working with 4 things. First thing, security policies. Second thing, you are basically working with the net rules. Third thing, you are working with the layer 7 inspection, which includes your URL filtering, your file policy, your vulnerability protection profiles, such kind of layer 7 inspection profiles. And the last thing, you are working with the VPNs. These are the core functionalities of an firewall, and we will see these things in detail, how they works. Okay. Now, so we will see like IPsec site-to-site VPN between 2 Palo Alto devices having the static IP at both the end. But here we will use pre-shared keys. In the another example, we will see how we can use the certificates. Then we will see if both the site having the overlapping subnet, then how we can configure the VPN. Then we will see Palo Alto IPsec site-to-site VPN between 2 Palo Alto devices, where one end having the IP address from dynamic. IPsec site-to-site VPN between 2 Palo Alto devices, one end or one peer behind the NAT gateway. Dual IPsec site-to-site VPN. In that case, let's suppose you are having a dual ISP connections. Then how you can configure the active passive tunnel? Like one tunnel is active, when your primary ISP goes down, then your secondary tunnel it came up. So how we can do that? So we will see all these 3 things. We can achieve this particular setup by configuring the tunnel monitoring, by configuring the static route path monitoring, or we can use the 2 virtual router based policy based forwarding. Then we can say Palo Alto VPN tunnel between Palo Alto Firewall and Cisco ASA. Then between Cisco and Palo, where one end having the IP from DSCP, configured the route based IPsec VPN using OSPF. So how we can configure the VPN where we can also create the OSPF adjacency, which means we can forward the OSPF traffic through our IPsec tunnel. And we can also see how an spoke IPsec VPN configuration. And after that, I'll just move towards the most important topic, which is Palo Alto Global Protect. In Global Protect, we will see Palo Alto Global Protect connection flow, which means how your GP works in actual. How many SSL tunnel has been created in case of GP. Then we will see Global Protect connection method. User logon, on demand, pre-logon, then on demand, pre-logon, then user logon. So we will see all these in details. How we can configure them, what are the use case for these particular methods, we will see in detail. And after that, I move towards the management and reporting, how we can configure syslog, how we can configure netflow, what are the different log types we are having, then dashboard, basic logging, basic reporting, panorama. So we will have a one class on panorama, but whoever enroll for us for this Palo Alto course, we will give you a one voucher, so you can get our 7 hours of panorama course. So which you can basically, where we have covered all the concept with regards to panorama. And after that, we will also discuss active passive high availability, how we can configure the active passive HA, what is the active high availability, how we can configure active HA, and we will see all the 3 deployment mode of your active HA. Floating IP HA lab, our float share HA lab, then mixed mode HA lab. Then we will see the troubleshooting. So I will run through one troubleshooting webinar where I will explain the packet filter, packet capture, flow basic, and TCP dump. How we can use these particular utilities for troubleshooting any problem of your Palo Alto firewall, because I will tell you the ways how you can create a filters, how you can take the help of these filters to capture the packet, to check the global counters, to find out the problems, and how you can do the troubleshooting, how you can use the TCP dump command to capture the management plane related traffic. Then I will also give you how you can do the management plane troubleshooting and how you can do the data plane troubleshooting. So this is the things which I will basically cover in your Palo Alto firewall. So this is all about your course content. Now let's move towards the today's topic, guys. So today's what I will tell you what are the different labs topologies which I'm gonna use throughout the training. Then we will discuss what is the difference between next generation firewall and legacy firewall and why we are here to learn Palo Alto. Then I will tell you how stateful inspection works. Then we will discuss the SP3 architecture of Palo Alto firewall. So let me just go through with the lab topology. What are the lab topology I am gonna use? So I'll go here into my EVNG. So this is my first lab topology, guys, and for my 80% practicals, I will use this particular lab topology where I have one Palo Alto firewall. This Palo Alto firewall have a connectivity with the outside, with my home Wi-Fi, and behind this outside network, I have one Kali Linux machine. From this machine, I will basically launch the attack on my Palo Alto through my Palo Alto firewall on these particular machines, on these particular servers. And we will see how Palo Alto firewall is protecting us. In my inside network, I am having one Linux machine and one Windows PC. So I will use these machines for generating the traffic for testing purpose. And here I am having my two Linux servers. On these Linux servers, I will run multiple services like your SHS, Telnet, HTTP, HTTPS, all such kind of web services I will run, even though I will also configure some kind of application services here, and I will try to access these applications from the outside. So we will verify how we can basically add the security. Then I will have one more interface on Palo Alto 5, which is connecting with my VMnet 8, where I will get the management related stuff. So I will use the separate management subnet, separate inside network, separate DMZ network, and separate outside network. So this is the one lab, one topology which I'm gonna use. Apart from this, I also use, there's a one topology for HA. So this is the topology which I gonna use for your high availability configuration or high availability lab for active passive and active active. So this is the topology which I will use for these particular two labs. Come back and let me go here into my redundancy topology. So this particular topology I will use where I am having two ISPs. So where we will see how we can basically configure the policy based forwarding, how we can configure the path monitoring, how we can configure the ECMP, because almost all the organizations nowadays they have a two ISP setups, right? So how we can forward the traffic between them, how we can configure the static routing into this segment, then how we can enable the communication between these two segments, your inside and your DMZ. So this is the one of the topology I'm gonna use. Now, apart from this, I will use for VPN classes, I will use this particular topology where I am having my Palo Alto Firewall head office. I have Palo Alto Firewall 2, which is my branch office 1. Then I have Palo Alto Firewall 3, which is my branch office 2. And I have a Cisco SA Firewall, which is my branch office, or we can say this is my customer network. And this Palo Alto 5 have a connectivity with two ISPs, right? You will see they are having the interconnectivity, right? So this particular setup I will use for your VPN classes. So I can able to simulate all kind of use cases with regards to VPN. So these are the left topologies which I'm gonna use throughout the sessions. Okay. Now, let's discuss what is next generation firewalls and what is legacy firewall and why we are here to learn Palo Alto firewall. So, what we will do, so I'll go here into my whiteboard and let's discuss the things. Just give me 1 second, guys. Yep. Okay, cool. So, if I take an example here, let's suppose I will just draw one legacy design. So this is the legacy firewall design where I'll just have one firewall and I will put here most used firewall, which is your Cisco ASA firewall. It's a legacy firewall, right? So generally we have here ASA firewall. We have here your LAN infra. And here we are having your WAN infra. This is the internet. So we have here ISP provider and here we are having your internet users. And apart from this, we do have here DMZ infra. Now, on this ASA firewall, when we will control the traffic, right? So we will control the traffic on the basis of your layer 3 information according to your TCP/IP, TCP/IP or OSI model, right? Layer 3 information includes your source IP and your destination IP. We can also able to control the traffic on the basis of your layer 4 information, which is your source port and your destination port, right? So guys, in legacy firewall, we are only able to control the traffic on the basis of layer 3 and layer 4 information. Now let's suppose there is a one hacker. This hacker is sitting here and here is a one server. Let's say it's a web server. Now that's for web server hosting the web service on port 8080. Let's take an example. Now what this hacker he has done, he has created one malicious payload. He has created one malicious payload and what he will do, he will just try to send the HTTP request towards this web server. So he will send here HTTP get request, right? In this get request, what he has done, he has added this malicious payload. Now, this malicious payload he has added at your layer 7, at your application layer header, right? Now, because this firewall, he is not able to detect this malicious payload. Why? Because he is only able to inspect the traffic on the basis of layer 3 and layer 4, right? He will not able to understand your layer 7 content, right? So what will happen here? As this firewall, he will not able to understand the layer 7 content. So what now? This particular malicious code or payload is installed into this particular server, which means now this server is hacked. This server is compromised. Now let's suppose apart from this server, you have here 20 more servers. So what happens now? Now this particular malicious code, he will start spreading, right? And it will spread towards all your 20 servers. And now your network is compromised. Now, if you want to protect from such kind of attacks, what you need? So you have a legacy design here. So what you need if you want to protect this particular attack, now you have put here one device which is known as IPS, right? You have put here one IPS device. Now this IPS, he will basically protect you. This is the one use case, right? Now let's suppose we have one user here Now this user, he's a network engineer, or that user, he is from the IT team, right? And let's suppose this user, he has done one mistake. There is a one malicious site over the internet. This is the malicious domain. Let's take example of abc.com. Now what he has done, he is trying to access this malicious site. By mistakenly, he has accessed this site. And because it's a malicious site, so now let's say from this site, some kind of malicious code is installed into this machine. So guys, here by using this IPS, we have just saved our DMZ resources. Now, from this user, how we can basically put some restriction on the firewall so he cannot able to access this particular malicious website. Because it's a legacy firewall, so we can only able to put the restriction on the source IP, destination IP, source port, and destination port, right? But let's suppose this website is changing his IP address and port numbers dynamically. Maybe today this website is running on port 8080. Maybe tomorrow he start running on 8081. Maybe next day it start running on 443, and his IP address is also changing every day. So in that case also your firewall will not able to protect you. Now if you want such kind of protection from these malicious websites or malicious domains, what you have to do, you have to purchase one more solution. That solution is known as a, we can say, proxy. You need a proxy solution for web traffic, or I can say in Cisco terminology, you can go with the WSA, which is iron port, because WSA provides you the URL filtering solution, right? So now what here we are doing? Now, what we are doing here, let's suppose after some days, this particular user, there is another user, let's say this guy is sitting here, and he's accessed one of the website over the internet. And then now that website, what he has done, he has sent some kind of sleeping virus into this machine. Now this virus, he just got activated after 30 days. Now how you will protect from such kind of things, right? Or let's suppose on this machine he has downloaded some of the file, and that file having some malicious code. It's a sleeping malicious code, and it's got activated after 30 days. It's just some kind of spyware. So when it gets activated now after 30 days, what is start collecting the information of your network, and he's just trying to send that information to the hacker server. Now how you can get the protection from such kind of problems, right? So whenever you will have a new issue, you need a new particular solution, right? Like we have here IPS, then proxy, then maybe we need here one more solution which is known as AMP, which is advanced malware protection, right? So now how your Palo Alto firewall solve this problem? Because Palo Alto firewall, it's a next generation firewall. It's a next generation firewall, which means in Palo Alto firewall, you can restrict the traffic on the basis of layer 3, layer 4, and on the basis of layer 7. Now you can use all these particular headers. Now your Palo Alto firewall inspect the layer 7 headers, and it will provide you the access, or it will restrict the access, right? So what happens, your proxy solution, which is your URL filtering, your AMP solution for malwares, for spywares, your vulnerability solution for vulnerability protection, your virus protection for spyware protection, you will get just all these things in just in one box. That is the one of the biggest reason your Palo Alto firewall gain lots of popularity, because when Palo Alto firewall launched in 2005, it is the first firewall who has all such kind of features in just one box along with the SP3. Okay, so we will come on this SP3 later. Now, let me make some space here. Okay, so let me just come again with the next generation firewall, legacy firewall. So guys, if you have a next generation firewall, which means, now let's discuss the NGFW. So in next generation firewall, what you will get? You will get the app ID. What is the meaning of this app ID? App ID means application identification, which means when you will write your security policies on the basis of layer 3, layer 4 information, you can also write the security rules on the basis of app ID. In app ID, what you will get the control on your application access. You will get the granular control over the applications, which means if I take example of Facebook, the most popular application. So if I take example of Facebook, then Facebook have multiple applications. It is having Facebook base, which contain the base code of your Facebook. Then we have a Facebook games. We have Facebook chat. We have Facebook post. Multiple Facebook applications are there, right? Now, by using this app ID feature, what you will get? You just need to allow the Facebook base. You can allow, just block the Facebook chat, so people is not able to do the chatting. You can just block the Facebook games, so they will not able to play the games over the Facebook. You can block the Facebook video. So if some kind of videos are streaming on the Facebook, they are not able to access them. Just give me 1 second, guys. Okay. So with regards to app ID, you will get full control on the popular applications like Facebook, Google, Instagram, Netflix, YouTube. You will get the granular control over there. Okay, and you can put the restrictions. So that's why this app ID is very helpful. But there's a few other reason as well for this particular app ID. So let's take example one of the scenario here. Let's suppose I do have here Palo Alto firewall, and in my LAN I have two systems. This is PC1, this is PC2. In this PC1, I am running here BitTorrent. Let's say one of the user, he is running BitTorrent here, and this particular PC2, he is running here Yahoo Messenger. Now, as per your firewall policy, you have blocked the BitTorrent and Yahoo Messenger. So this is your internet service provider, and these are the servers of your Yahoo Messenger and BitTorrent. Okay. Now let's take example. Let's suppose here instead of Palo Alto firewall, you are having Cisco ASA. Just think this is a Cisco ASA for some time. And on this ASA firewall, you are having one rule where that rule is saying if traffic coming from LAN going towards WAN or going towards outside, traffic coming from inside, going towards outside, and port number is 53. So UDP 53 for DNS. And you do have a one more rule, if traffic coming from inside going towards outside on port 80 and on port 443. Let's suppose default port for BitTorrent is 5050 and for Yahoo Messenger 5060. These are the two TCP ports which are open into these servers. Okay, so and you are having a block rule as well. You are having a block rule. If traffic coming from LAN or inside going towards outside, a port is 50-50 and 50-60. You are blocking this traffic on the ASA. So guys, just remember one thing. These servers generally, what happens, these are the default ports on which they are running or they are listening. But what they will do, they will open their request into almost all the well-known port numbers. Okay, they can able to listen for the request on the well-known, all the well-known port numbers, which is port is starting from 1 to 1023. These are the well-known ports, right? And in this ASA, we have allowed here DNS traffic, HTTP and HTTPS traffic. So what these applications they will do, they will first send the request on their default port 50-50. He will send on 50-60. But as soon as they will get, oh, that request is blocking here, what they will do now, they will start sending their requests into the port number which is starting from 1 to 1023. And when their request reached on port 53, they gain the access, right? Their request will go here, which means these are the evasive applications. Evasive application means if their default port is blocked, what they will do, they will start sending the request into some other ports to bypass the firewall. Now they are just bypassing your ASA firewall, right? Because your ASA is just blocking the traffic on the basis of source IP, destination IP, source port, destination port, right? But these values are not fixed for them. And these are evasive applications, right? So such kind of application control you will not get. You will not able to restrict the BitTorrent or Yahoo Messenger traffic by using this ASA firewall. Now, if we have a here Palo Alto firewall, so what benefit you will get? In case of Palo Alto firewall, what he will do, whenever he receive a traffic from BitTorrent, what he will do, he will basically send this particular BitTorrent traffic through the app engine. He will send this traffic to the app engine, where this app engine, he will identify, he will look into the layer 7 content of this traffic, and by looking into some defined pattern, some defined signature of this BitTorrent traffic inside the Palo Alto signature database for app ID, he will able to identify, oh, this traffic belongs to the BitTorrent. Now my firewall is not allowing the traffic on the basis of just your source IP, destination IP, source for destination, not. It is also checking the application, right? So by looking into the pattern, it will identify. Now let's suppose this BitTorrent, you send the request on port 53, right? So initially you will see, oh, this request is for DNS, but in actual, this is the BitTorrent request, right? So now your next generation firewall, or we can say Palo Alto, he can able to identify this traffic easily by using the app ID signature database. So such kind of benefits you will get if you have a app ID feature enabled in your Palo Alto firewall. Just remember. Now, the second feature of your Palo Alto firewall is URL filtering, or we can say any next generation firewall, which is URL filtering. Now, why this URL filtering become very, very popular? Because if you have seen, if I take example of Palo Alto firewall, it just have a support of 3,500 applications. If I'll take example of Flipkart, so for Flipkart, my Palo Alto firewall is not having any kind of application. Now, if you want to restrict the Flipkart traffic, how you will restrict? And if I'll take an example in the across the globe, we are having around 3 million websites. How we can control the access of these particular websites? which means for that we need some kind of solution. So what it will do, we have a URL filtering. So in URL filtering, what it will provide, it will basically provide you the control over your web traffic, means traffic which is going on HTTP and traffic which is going on HTTPS. So let's suppose you want to put some restriction, like you want to block all the social networking site, or you want to block all the pornography sites, or you want to block all the malware related websites, or you want to block all the gambling websites. So for that, if you want such kind of protection, you have to go with the URL filtering solution of your next generation firewall. So this is the one of the best feature of your next generation firewall. Now the third thing which you will get the virus protection. So if I'll take example of this virus protection, so let me just make some space here, guys. Let me just clean it up here. Okay, so in virus protection, what happens generally? These kind of virus, basically how we will download, we generally download by using either we are accessing any website or over HTTP or HTTPS, either we are transferring some file by using FTP or SMB protocol, or we are using some kind of mail protocols like your SMTP, your IMAP, and your POP3. These are the few popular applications which we use for the transferring the data, right, over the web. Now, generally these viruses, what happens, they will come through these particular protocols. And if we put some restrictions, or what we will do, if we will start inspecting the traffic of these particular protocols, what we will do, we can able to detect the virus code on our firewall. We just need a signature database. How your IPS it will able to detect these viruses and all, because it is having the signature database. And generally you will see most of the organization, they are using the snot feeds for basically detecting the viruses. Okay, so paloalto will also do the same thing. What, whenever we are downloading any files or transferring any kind of data, it will inspect each and every byte of that particular data to detect the viruses. If he find any kind of virus, what he will do, he will basically stop the traffic at that particular moment. It will start discarding that particular traffic, and it will drop all the connections. So that's how you will get the virus protection. Apart from this virus protection, you will also get the anti-spyware protection, or we can say spyware protection and DNS protection. You will get the protection from spywares and DNS. You can also able to control your file upload and downloading of files. You will get the file protections. You will get the data protection. If you have some kind of confidential data, you can also protect that particular data. You will get the user ID feature here. So you will get the vulnerability protection. So such kind of layer 7 protections you will get with regards to your next generation firewalls, and your next generation firewall is able to inspect the traffic at layer 3, at layer 4, and at your layer 7. Now let me write down few next generation firewalls here. So the first firewall in your next generation list is Palo Alto. Second firewall is your Fortinet. And the third firewall is, we can say, Cisco FTDFMC. and the fourth one is your checkpoint. These are the four most popular next generation firewalls, and Palo Alto Firewall, he is the leader in your firewall industries, and he is the leader from 2008 till today. So since 2008 till today, Palo Alto Firewall is leading the firewall industry. Now, let me just write down few legacy firewalls here. In legacy list, number one firewall is your Cisco ASA. Then we have a Juniper SRX. Then we have a like a Sophos firewall. We have a Dell firewall. We have a HP firewalls. We have a Cyber Roam, right? All these firewalls, they comes under your legacy list. And your legacy firewall, they will only able to inspect the traffic at your layer 3 and at your layer 4, and you will not get app ID, URL filtering, virus protection, spyware protection, file protection, data protection, user ID, vulnerability protection. Such kind of protections you will not get into these legacy firewalls. That was the biggest reason of your nowadays everyone is using next generation firewalls for controlling the traffic. Okay, so this is all about with regards to your legacy firewall. Why we have chosen here Palo Alto Firewall? Because Palo Alto Firewall, when they have launched Palo Alto Firewall in a year 2005. So it was the first firewall who come up with the app ID feature, who come up with the user ID feature, who come up with the content ID feature, which includes your URL filtering, your antivirus protection, anti-spyware protection, your file protection, data protection, vulnerability protection. This was the first firewall who come with all these features just in one box. And when you enable all these features, it will provide the very, very high throughput due to its SP3 architecture. SP3 stands for single pass software parallel processing hardware. And just they have launched this in 2005, and just in 3 days, 3 years, in 2008, as per the Gartner report, it becomes the number one firewall in the market. And since 2008 till today, he is the market leader. That is the one of the biggest reason we are here to learn Palo Alto Firewall, because Palo Alto Firewall is the most used firewall in today's industries. Every organization, they are using Palo Alto today in their organizations. Okay. Now let's discuss what is stateful inspection. Okay. So guys, I will explain this stateful inspection with regards to any firewall, and you can, after that, we will relate the same thing with regards to Palo Alto Firewall. Okay. So let me go into this. Let me make some space here. Okay. So let's suppose I am having a such kind of design where I have a Palo Alto. I do have a one firewall. It's not Palo Alto. You can think any firewall for now. We have one of the PC in my LAN side. This is my inside network. And this is the PC in my inside network. He's having IP address which is 10.1.1.70. I do have one of the server in my outside. Or let me just make it, this is my DMZ zone, not outside. In DMZ, I have this server. That server having IP address 10.2.2.101, and it's a web server. And this server is hosted on port 80. In this server, I'm having one of the file of 2 GB. This is the one of the MP4 file. Now on this PC, what he wants to download this particular file from this web server, because it's hosted on port 80. So what will happen now? So just think about, this is a Palo Alto firewall for a minute. So when this PC will send a request, so generally what will happen? He will send first request. And if I draw the diagram here, draw the communication. So always your first request is your send request, because this server, it's a web server hosted on TCP port 80. So what's first, they have to complete the TCP three-way handshake. So now when this send request received by the firewall on the interface, let's say Ethernet 1/2, this is Ethernet 1/3. Receive that request on Ethernet 1/3. So what it will do now? Now this firewall, he will start processing that this send request. So how it will process in case of Palo? So it will process first at the ingress stage, then it will do the flow lookup, right? Now guys, what is this flow lookup? This flow lookup is the only thing which come due to the stateful inspection. Okay, so what we will do, we will come back to this particular communication later. Let me just tell you the flow with regards to the router first, because in router it's a stateless device. So first we will try to understand the stateless inspection. Same setup, same PC here, same IP 10.1.1.70. This is the router this time. Router is a stateless device. It will not support stateful inspection. Same server. 10.2.2.101. It's a web server hosted on port 80. It is having just 2 GB of .mp4 file. Now this PC wants to download this file. So what will happen? So if I write down the communication here, so your first request is always initiated by this PC. So they have to complete the TCP three-way handshake. It's a send request, now reaches to the router. So now when this router, he will process this request. So let's suppose it will process at ingress stage level, right? Then it will check the routing table. It will check the SEF table. If net is there, then it will basically send this traffic to the net engine, right? If we have ACLs, then it will also send this traffic through the ACL engines, right? So all these kind of checks it will perform. So which means if it's a Cisco router, so it will do around here 27 checks. It will send this traffic through these 27 checks, guys. And where the main checks is your routing lookup, your net lookup, and your ACL lookup. These are the main checks in case of router. Okay. Just process this send request. Let's suppose these 27 checks, they just took around 1 second. He will forward this send request here now. After processing this request, right, he will forward this traffic through this interface. Then from other end, he will get the send plus ACK. Then ACK he will receive. He will again process these ACK requests through all these 27 checks. And he will forward this request over the PC. It's a send plus ACK packet. And now he will get the ACK from here. That ACK message, he will again go through these all 27 checks, right? And after that, he will send the HTTP GET request for accessing this file. This HTTP GET, again, it's take 1 second. It has to go through all these 27 checks, right? Then he will get the HTTP response. He will also get HTTP response will also processed by this router. So Now let's take an example here. Let's suppose to download this entire file between this PC and this server. Let's suppose they have exchanged around, they have sent around 200 requests, and he has also received 200 replies, which means now this router, when he has processed this particular request for downloading of this file, how many seconds it will take? It will took around 400 seconds for processing this entire request, because your router is a stateless device. Okay. Now, if I'll go back to here into my firewall, this is my firewall design. Okay. So what happens, guys? Whenever we have a firewall, when my firewall he receive a send request, right? So if you will see this send request, he is having such kind of packet. That packet have the source IP, which is 10.1.1.70, and the some port number is also there. Let's say port number is 1234, which means what? You have a here source IP and you have a here source port. This is your source socket, right? Then we have a some destination socket as well. Destination is 10.2.2.101 and port is 80. So here you have a destination IP and your destination port. This is just now. So when your firewall he received this send request, what he will do? He will put this request at the ingress stage. I'm not going in depth, guys, what are the things it will do in ingress stage, because that's a part of your packet flow, life of a packet in PAN-OS. Okay, I will just go with the overview here, right? Then it will do the flow lookup. In flow lookup, what it will check the state table. Due to in stateful inspection, if any device who support stateful inspection, what they will maintain the state table, and you will see it's just a first packet, right? So it will not have any entry into the state table. So what it will do now, this request will go through your session setup state, state stage, or we can say your slow path. In session setup state, what will happen? It will basically do the major checks, your routing table lookup, your net policy evaluation, your security policy evaluation, your user base policy evaluation. All these things happens into your session setup state. Here it will do the zone protection policy lookup, your DOS protection policy, right? All these things is a part of your session setup state only. And let's suppose in our security policies, we are allowing the traffic. And if we are allowing the traffic, in that case, what my firewall do? It will basically store that particular entry of this particular session into the state table. What it will save the source IP address, source port, destination IP address, destination port, your layer 3 protocol information, and your ingress zone information. It will store these 6 tuples. What it will do, it will store these 6 tuples into this state table. Okay. How it will store, guys? That's a different story. Generally, it will run the MD5 hash here, and it will store. So for storing that info, it needs some kind of database. So in case of Palo Alto, they will use here MongoDB database in a backend. They will use this MongoDB database for storing this particular information. That information is known as flow key. Just remember this information, this MD5 hash value is known as a flow key. It will store this flow key into the MongoDB database. And after that, he will return your packet for the next check, which is your fast path. In Palo Alto Firewall, we do have a app engine as well, like app ID and your CTD engine, which is your content ID. Just guys, remember your SYN packet, it will not go through with this app ID and content ID. Just remember. Why it will not go? Because your SYN, it is not having any kind of application data. Just remember, it's just an empty packet. And the last thing, it will go for the forwarding. Now let's take one example. For all these particular checks, let's over my firewall, it's take around 1 second. Okay, he took 1 second for processing all these checks. It will done in 1 second for TCP SYN request, right? And after that, what he will forward this SYN request towards the server, right? Now the server, he will give the reply. So he will send the SYN plus ACK. Here also he will get the SYN plus ACK. When he received the SYN plus ACK, how my firewall process this SYN plus ACK? So if I write down this info here, what it will do? It will just process against your ingress, stays, and then it will do the flow lookup into your state table, or we can say into your state table is also known as guys session table. So don't be confused, or it will also known as flow table, or it is also known as connection table. Different vendors, they will use different names. In Palo Alto, this is known as flow table or session table. Okay, so because this time we have an entry of this particular traffic into the flow table, so what it will do, it will bypass your session setup state, which means it will bypass your routing, your net, your security, your user base policy, your zone details, your DOS policies, all these things it will bypass. And these are the major thing, guys. They really took some time. Okay. So now this packet directly go into your first path. And after that, your packet go directly towards your forwarding state. It will not go through this app engine, guys, and content engine as well, because your TCP SYN plus ACK and your ACK packet, they will not go through this particular engine. And after that, you will see, we will receive here HTTP GET request. Now, when my firewall, he received this HTTP GET request. Now this HTTP GET and the subsequent packet, it will send through your ingress stage, then your flow lookup, and flow is already there. It will go towards your first path, then your app ID, then your CTD, and then your forwarding. Okay, so it will process like that. Your HTTP GET request, same it will process for HTTP response. So now whatever traffic with flow between these machines, what it will do, it will process according to this part. But it will also bypass the app engine, guys. It will not send the traffic every time through this app engine, because once app is identified, it will only send the traffic through CTD, just to detect the application shift. If there is any application shift happens, like we are using initially Facebook, let's suppose now we have just shifted to the Facebook Messenger, which means we have done the application shift, right? So to detect this application shift, it will always go through the CTD engine, and CTD, it will also take care of your spywares, URL filtering, your antivirus, your vulnerabilities, all kind of content inspection, right? So now if you will see the difference here, your send request, that request is processed in just 1 second, right? And after that, the other remaining request, my firewall will just process into 1.5 seconds, because it is just completely bypassing the session setup state, which is the major state. And let's take example. This transaction is took around, we have sent around 200 requests, and we have received 200 replies. Total 400 requests and replies. So now how many seconds we have taken for processing this request? It is nearly 200.5 seconds. This is the difference, guys. And I have here Palo Alto firewall or any firewall. See the difference due to the stateful inspection. In router, it took around 400 seconds for processing the same request, but in case of firewall with the stateful inspection, it is just taking the half time. So that's why, guys, your stateful inspection, it's become very, very popular in the market. And guys, let me just tell you some interesting story behind this stateful inspection. So in stateful inspection, what happens? All your devices, they will maintain something called a state table. In this state table, generally, in case of Palo Alto, it will store your source IP, destination IP, source port, destination port, protocol, and your ingress zone details. Okay, and this particular technology is developed by the person. His name is Nirjuk. He is the guy who has developed this particular stateful inspection when he was a part of Checkpoint tech team. He developed this technology, and after that, so he had developed this technology in 1993, and after that 1994 onwards, all your vendors like your Cisco, your Juniper, they have started using that particular concept of stateful inspection into their firewalls. And due to this stateful inspection concept, it has just changed the entire behavior, or it has changed the entire inspection behavior of your firewalls. Now your firewalls become very fast. They are processing the request very fast due to this particular feature. And guys, Nirjuk, he's the same guy who has basically developed or designed your Palo Alto firewall. And he's the owner, or we can say CEO of your Palo Alto firewall. And he has launched his Palo Alto firewall first time in 2003. He failed. He went back and he just again come with the lots of good features in 2005. And just in 3 years of time, he become the market leader in the firewall industry. So that's how your firewall, or that's how your Palo Alto firewall started evolving. That's some history of your Palo Alto firewall. And that's how your stateful inspection helps the firewall to inspect the traffic with the high throughput. Okay. Now, let me just discuss the last topic of today, which is SP3 architecture. I will not go in too much detail of this SP3 architecture, guys. I'll just go with the basic of it. So for that, let me just go into this diagram, and this diagram is more than enough to explain this SP3 architecture. Okay. So in Palo Alto firewall, they always said they have supported stateful they are having SP3 kind of architecture, single pass software, parallel processing hardware. This is the full form of your SP3 architecture. So they have a single pass software and parallel processing hardware. So guys, what happens in Palo Alto firewall generally, what they are having their control plane, or that plane is also known as your management plane. This management plane, and they also have here data plane. So Palo Alto firewall, they have basically separated their management plane and data plane. Your management plane, it is having dedicated resources like dedicated CPU, dedicated RAM, dedicated hard disk, dedicated management port, and dedicated HA1 port. Okay. And your management plane is responsible for your configuration management, logging, and reporting. And Palo Alto data plane, what they have done, they have divided this into three parts: signature match processor, security processor, and network processor. So these are the three different planes, or difference three different processor of your data plane, which means they have divided its data plane into three further small planes, we can say. And now these planes, they will do their dedicated jobs. Your networking processor is responsible for doing your net, quality of service, ARP, route, or flow control, which means it can able to understand your layer 3 information, and your layer 4 information is taken care by the network processor. And just guys, remember one thing, this network processor is taking care of your session offloading. This particular processor is also known as a session offloader. And after that, we have a security processor. That processor is responsible for your session setup, which means this is the processor who will basically process the user's traffic against your security policies, net, everything is done by the security processor. And this processor, it is having dedicated chips for your SSL, for IPsec, for decompression traffic. So these chips, they will basically take care of your SSL decryption, your IPsec traffic, or your decompression traffic. It is having dedicated RAM, dedicated CPU. And we have a signature match processor, which is take care of your app ID and content ID, which means your virus protection, your spyware, your command and control, exploits, all these kind of things is take care by the SP3 engine or your signature match processor. And it is having your dedicated RAM and dedicated CPU. So if I draw a block diagram of Palo Alto firewall, you will understand everything. So guys, in Palo Alto firewall generally, what happens? Let me, if I'll draw a block diagram here. So first of all, you will see here, these are the Palo Alto interfaces, or we can say ports. So let me just put the ports details here, like starting from Ethernet 1 by 1, then Ethernet 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, 1 by 7, 1 by 8, 1 by 9, and let's say 1 by 10. We are having around 10 ports on my Palo Alto firewall. Now these interfaces, they have a direct connectivity with one of the chip. That chip is known as Marvel chip. And you will, in some high-end boxes, like in the some high-end Palo Alto platform, you will see the Petra chip as well. This Petra chip is for SFP plus ports. So if you are having fiber ports, these ports, they have a connectivity directly with the Petra chip. Your normal Ethernet port, they have a connectivity with the Marvel chip. And all these ports, they have connected like this. Now this Marvel chip, it is having a direct connectivity with one of the processor, or that processor is known as a network processor. It's just a FPGA, field programmable gateway array. And these particular two chips, they have a connectivity with high-end links. These links is known as joy links. And that particular network processor, it is the chip name for this is known as Liger in high-end boxes, and sorry, Liger in low-end boxes. If you will take a high-end boxes like 5000 series or 5200 series, you will see the Tiger chip there. Then this particular processor, it has a connectivity with one of the chip. That chip is known as a Octeon chip. This Octeon chip is known as a DP-CPU, data plane CPU. And this is the chip who will basically process the packet according to life of a packet in PAN-OS. Now this chip is responsible for your ingress, your connection setup, everything. Network processor, it will only process the offloaded session, guys. It will only process the offloaded session. And after that, you have a one more chip here. That chip is known as a Jaguar. This Jaguar chip is responsible for your app ID and your content ID. Now this is also one of the FPGA, field programmable gateway array. So this is the block diagram of your Palo Alto firewall. Your Palo Alto firewall is a combination of all these particular internal chips, and these chips, they will basically do the processing. Now this Jaguar, it is responsible for doing your app ID and content ID. So in this, there is a two algorithm. First algorithm is known as AHO. The second one is DFA. These two algorithm runs on this Jaguar chip. So this DFA algorithm is responsible for your app identification. And your AHO, nowadays, guys, it is in with PAN-OS, latest code of PAN-OS like PAN-OS 10. It is replaced with the new algorithm known as a PS scan. Now this particular algorithm is responsible for doing your content identification. So your content identification done by the Jaguar chip, and in this Jaguar chip, there is a one algo is PS scan. This algo runs and it will take care of all these particular stuff. So this is how the block diagram looks like in case of your Palo Alto firewall. So guys, when we say SP3, single pass software, parallel processing hardware. So guys, you will not get this kind of architecture in all the Palo Alto models. You will see this SP3 kind of architecture in high-end boxes like your 3200 series box, your 5000 series box, your 5200 series box, your 7000 series box. These boxes, they will support this SP3 kind of architecture. If I'll take example of like 200 series box, your 800 series box, or like the old series, which is 2000 series, they will not support the SP3 architecture. Just remember, maybe in 200 box, it is just having your Octeon chip. Only this chip is there. These three chips is not there. Your interface is directly connected on Octeon chip. In 800 box also you just have only one chip, which is Octeon chip. Okay, so do not confuse, guys. SP3 is not supported on all the hardware models. Okay, now let me show you one more diagram so it will clear all the things. So if I'll go here, if I'll open this diagram, so if you will see, generally Palo Alto architecture is looks like this. We have a control plane. This is also known as management plane. In management plane, it's a dedicated management plane, and we are having a dedicated multi-core CPU, dedicated RAM, and dedicated hard disk. Then we have a data plane. In data plane, we are having the three: network processor, multi-core security processor, and your signature match processor. These are the same processor which we have discussed. And if I'll say, this is known as your Octeon chip. This is your Tiger chip, and this is your Jaguar chip. And you will see your Octeon chip, it is also having dedicated SSL engine, IPsec engine, and decompression engine for doing the complex task. This is how your Palo Alto firewall architecture looks like. It's a parallel processing architecture, which means these engines, they can work parallelly. They don't have any kind of resource level dependency on each other. They are having their dedicated resources, so they can work independently. Even though your Octeon chip, it's a multi-core CPU, you have a multiple CPU here, and all these CPU, they will able to process the traffic. Like we can say one man who is having the 16 hands here with the 16 CPU. So he can able to perform 16 jobs together. So that's how your things works, guys. Okay. And that is the one more benefit you will get in Palo Alto firewall due to parallel processing architecture. The thing is, let's suppose you got some kind of problem with your data plane. Maybe one of the chip is not performing well. What you can do? You can restart your data plane. You do not need to restart your management plane. That kind of flexibility you will get. Let's suppose there is some issue with the management plane resources. And guys, just remember one more thing. Palo Alto management plane is a Linux operating system in a backend. You will see the daemons are running here. All kind of daemons are running here. Now, if there is any problem with the management plane, you can restart these particular daemons or these processes. You don't need to restart the entire box. So such kind of benefit you will get due to this segregated architecture of your Palo Alto firewall. Okay. Now, I was also, let me just before binding up this session, guys, just give me 1 second. Let me show you one more diagram of 5,000 box, because in 5,000 box you will see 3 Octeon chip, and this particular 5,000 box, or like your 5200 box or your 7,000 box, they have a 3 data plane CPU, 3 dedicated Octeon chip as there, and these are the devices who is actually supported your parallel processing architecture, because these devices, they can process the packet independently. It is having 3 CPU. Now these 3 CPU, they can take, or it is having 3 chips. Maybe for a session, one packet is processed by this, another packet is processed by this, or maybe third packet is processed by this at the same time, right? So, and if you will see in this diagram, these 3 CPU is known as these are the your Octeon chip, or we can say these are your data plane CPU. Then we have a signature match engine, which is your Jaguar chip. We have a 2 signature match engine here. In 50 to 60 box, you will get this additional chip here. And your security processor is known as Octeon chip. And we have here data plane CPU, or we can say this is your network processor, where we are having your Tiger chip. And we have this is your switch fabric, where we are having your Petra chip. So Marvel and Petra is a part of your switch fabric. And this is your management plane. So this is the actual architecture of your Palo Alto high-end boxes. And you will get SP3 kind of things in your high-end boxes, which means you will get parallel processing in your high-end boxes. Now, let me also quickly tell you the single pass architecture. Oh, guys, your actual SP3, if I say actual your SP3, it is applicable at your content engine. Your actual single pass architecture is applied at your content engine. Why? Because what happens in your Jaguar chip, let's suppose this is the generally when we want to process any packet. So we will store this packet into the RAM. Let's suppose this is the RAM. Here I have stored my packet. I have stored some bytes of my packet here. Okay. And now around this, we are basically having your all our engine, like your URL engine is there. Your antivirus code is running here. Your anti spyware code is running here. Then your vulnerability protection is there. Your data filtering is there. All these kind of engines are there, right? Your data filtering, your file engine, your wildfire engine, every engine is running here. So what they will do, whenever my paloalto firewall, he will store the packet, which means this packet is stored as it is having layer 7 content. What they will do, all these engines, they will load the packet from here together. They will load the packet together and they will process the packet together. And what they will do, they will just give the result to your pan OS and your packet go like that. So this is your single pass architecture, and your single pass architecture applicable only on your content engine. That's why in your content engine, you will see we have a multiple RAMs, right? Because these RAMs, they will store the packet. And now all these small codes, or these are the databases which we are running, or engines which we are running into your Jaguar chip. These engines, they will process the packet for the threats, malwares, for viruses, and they will basically provide you the result. Why your firewall is able to do that, and why this thing we are not able to apply on your Cisco devices or like other vendors like Checkpoint and all? Because these Checkpoint and all, they have not built their operating system from the scratch. What they have done, they have just added the feature on top of their actual engine. If I'll take example of Cisco ASA, which is running Lena, on top of Lena, he has just, they have added the snot engine for layer 7 inspection. But Palo Alto, because they have built their operating system from scratch, so that's why they can able to do this particular thing. So that is your SP3 architecture. And this is the last topic of today, guys. Now, let me just give you the mute permissions.